Hello everyone, good morning. So today we will start exercise 4C. So before starting off, let's just quickly understand what exactly the concept which are being required to do this particular exercise. So without wasting any further time, let's start. So the first concept is curve. So curve, as we all know, in general thinking, what we think that this is a straight line and it is not curve. Curve means something like, yes, where this shapes are being covering on, that is the tilt part should be there. But in mathematics, a straight line is also a curve. Why? Because in the definition point of view, when we are making a curve, the main and the key point which is being required, that we have to fix our point and move on like that way. We cannot lift our pen. So the figure which is being formed, that is called as curve. So I can make a straight line also, that is also a curve, because it is coming towards the definition of curve. So what exactly the definition it is? You can say that the figure that are obtained by moving the sharp tip of pencil aimlessly on a paper from one point to another is known as curve. So that means the figure which is being formed without lifting the pen or pencil, that is called as curve. Is it clear to all of you? Alright, so after that there is subtypes of curve which are called as simple curve. Simple curve means what? A curve which does not cross itself. So that means simple curve, that is a subtopic of curve. The curve which does not cross itself. Cross itself means what? A straight line. It is not crossing. Or you can say this figure is what? It is actually crossing itself at this particular point. So that means this is not a simple curve. Simple curve means what? Where we can, this is the figure. Let's see. This is a simple curve. This is also a simple curve. This is not a simple curve because it crosses itself. Alright, is it clear? So simple curve means what? A curve which does not cross itself. Curve which does not cross itself. Alright, move on to the next concept, that is open curve. Open curve. So what do you mean by open curve? Open curve means what? A curve whose starting point is different from the end point. Curve whose starting point is different from the end point. Alright, that are called as open curve. One more thing is that, so there is one confusion which is being created, that so that means simple curve and open curve both are same? No. Why? Because open curve means what? Where the starting point and the ending point are different, or you can say this one, or you can say this one. But in simple curve, this is also a simple curve. Why? Because the starting point and the ending point are same, but it doesn't cross itself. If I just make this one as this part, so that means this is not a simple curve. But if I just remove this part, then it becomes a simple curve. Is it clear to all of you? That the starting point and ending point, it actually making some difference. If the starting point and ending point are same, then it is called a simple curve. Or actually when it doesn't cross itself, or when the starting point and ending point are different, that are called as open curve. So what do you mean by the next concept? That will be closed curve. Closed curve means what? A curve whose starting point and ending point are the same. Starting point and ending point are the same. So that means closed curve are something like this figure. Starting point and ending point are same. This is starting point and ending point are same. but there is some difference with the simple curve. Simple, this is also simple curve, right? But this is not closed curve. This is not an open curve. Sorry, this is an open curve. This is an open curve, but this is not an open curve. There is some difference. All right, the mixture of open and closed curve are simple curve. The mixture of open and closed curve are called simple curve. All right, but simple curve is not open curve and simple curve is not closed curve. Is it clear to all of you? So that means when we just if I have one bag and I just put simple open curve and closed curve togetherly, so that bag, it becomes a simple curve. Is it clear to all of you? I guess it is so. So now let's just move on to our next concept, that is called as simple closed curve. Simple closed curve. Simple closed curve means what? Simple closed curve means what? It means, let's just see. The next concept will be simple closed curve. Simple closed curve. So simple closed curve means what? A closed curve which does not intersect itself in any other point. So that means it should be a closed curve. This is a closed curve. All right. So now this figure is what? Which I just created. This figure is what? This is an example of closed curve, not simple closed curve, because it actually intersecting the curve at this particular point. All right, but it is a closed curve. It is a closed curve. Why? Because the starting point and the ending point are same, no problem, but it is not simple closed curve. Why? Because it is actually intersecting at particular point. So that means when we are talking about simple closed curve, the best example is circle. Yes, because we cannot find out where it actually intersect, but in this figure I can easily find out that this point is the intersecting point. So we can say that simple closed curve are not this figure. Simple closed curves are this one, but it is a closed curve. It is a closed curve. Is it clear to all of you? Let me just summarize one more time. What do you mean by curve? Curve means what? Figure which is being formed without lifting the pan. These are the figures. All right, done. After that, simple curve. Simple curve means what? Simple curve means what? Where they did not intersect with each other. The curve which does not intersect with each other. So this is straight line. This is also a simple curve. All right. Now one more thing is that does not intersect with each other. So that means this is not a simple curve. All right. And any other point is there? No. After that, open curve. Open curve means what? The starting and the ending point, it should be different. Starting and ending point, it should be different. Closed curve means what? The starting point and the ending point are same. This is a closed curve. This is also a closed curve. This is also a closed curve. All right. But this is not a simple closed curve, because simple closed curve, it signifies that the starting and the ending point should be same. That is okay, but it doesn't intersect with each other. So here the intersecting point, it is clearly visible. So we cannot say that this is a simple closed curve. All right, done. Okay, fine. So let's just move on to our next concept, that is called as polygon. All right, one more thing, what I just think is that now you got the definition, or you got the concept. So let me just write down very nicely that how you can represent this the definitions, right? So let me just write this one, and you just copy this from the board. So these are the definitions that you can write out from the board, and after that we will move on to our next concept, that is called as polygon. All right, the next concept is polygon. So what exactly polygon means? Polygon is also a simple closed curve which is made up of line segments. That's it. It must be a closed curve which are made up of line segments. So for example this is. So but this is the what type of polygon it is. This is called as triangle. So that means the number of sides, it depends upon the number of sides. What do you mean by sides? Or number of line segments. So these line segments are nothing but called as sides. These line segments are nothing but called as sides of a polygon. Here different forms are there. Let's see. This is another shape that is called as quadrilateral. This is called pentagon. This will be hexagon. Like that way, different figures are there. So this is called as triangle, quadrilateral. This is pentagon, hexagon. Like that way it will keep going on. Alright. Okay, so after that, moving on to our next concept, that is called as vertices. And before that, sides. Let me just disclose what exactly side is. Sides are nothing but called as the line segment forming the polygon. The line segments, these are the line segments, no? These are the line segments which are forming the polygon. So the line segments forming the polygon known as sides. Simple. All right. After that, we have one more concept that is called as vertices. So what do you mean by vertices? Vertices are nothing but what is a meeting point of the pair of the sides, or you can say in this figure, these two sides, let's say this side and this side, these are meeting at this particular point. So this point is nothing but called as vertex. This point is nothing but called as vertex because it is singular once. But if you are talking about this side and this side, so this point is nothing but called as vertex, and as well as this point is nothing but called as vertex. So there are three vertices altogether. Alright, so the definition of vertices are the meeting point of two adjacent sides. Alright, so that is the definition of vertices. One more thing is that adjacent side. What do you mean by adjacent side? That is the next topic. Adjacent side. Adjacent sides are nothing but what? Which have one common vertex. Alright, so that means the endpoints of the same side of a polygon are called adjacent vertices or adjacent sides. Any two sides of a polygon with a common endpoint, or you can say vertices, the same thing. I think no need to write this one. Now the adjacent vertices. If the concept is not clear, let me just draw one figure for you. So let's say these two are adjacent sides. Because how? Because they have one common vertex. That's why. Alright, they have one common point, that the common meeting point. So the next concept is adjacent vertices. The endpoint of the same side of a polygon are called adjacent vertices. The endpoint of the same side of the polygon. Alright, so let me just draw one figure for you so that you can easily understand. Let's say this is the figure. Alright, so this point and this point, A and B, these two are adjacent vertices, nearby points, as well as A and C are adjacent vertices. B and C are the adjacent vertices of A. B and C are the adjacent vertices of A, and if you just compare with D, they are not adjacent vertices, non-adjacent vertices. Alright, so I hope the concept is clear to you. So let's just move on to solve the exercise of 4C. So here in question number 1, what exactly it is? Classify the following figures as open and closed. We know that how to mark that which one is open and which one is closed. So I just write down, this is what? This is open, this is close. Close, open, this one, close, open, close, open. Alright, so that is the answer of question number 1. Moving on to our next question, that is question number 3. Alright, so moving on to our next question, that is question number 3. Which of the following are polygons? So polygons is what? Made up of line segments. Closed figure, simple closed curve made up of line segments. So here, this figure is not a polygon. There is a polygon. There is a polygon. Not a polygon because mixture of lines and line segments and curve. So that means this is not a polygon. This is a polygon. This is polygon. Not a polygon. Not a polygon. Alright. Moving on, I hope these 2 questions are clear to you. Moving on to our next question, or you can say the last question of today's video, that is called as question number 5. Alright, so we are coming toward the end of this particular class. So the last question of today's video is refer to the polygon drawn in figure 1. This is the polygon and name the following. Pair of its adjacent side. Right? So what do you mean by adjacent side? Which have one common meeting point. So here AB and AC are the pairs. First pair AB and AC. Second one will be AB and AF. AB and AF. Third one will be AF and AE. AF and AE. Fourth one will be AF and FE. Sorry, AF and FE. Fourth one will be FE and DE. Fifth one will be DE and CD. DE and CD. And last one will be CD and BC. CD and BC. Is it clear how to find out? That the common point is over B. So that means AB and BC are AB and AC. Why did I write? AD and BC are the first adjacent sides. After that, what I just did, AB and AF. So AB and AF has some common point that is called as AF. Is it clear? Is it clear? Alright. So after that, we have AF and FE, AF and FE again, and after that FE and DE, DE and CD, CD and BC. Okay, fine. So let me just move on to our next question, that is points in the interior. So points in the interior, we know that these two are the interior points of P and R. After that, points on the polygon. So on the polygons are what all these points are on the polygon. So I can write A comma B comma C comma D comma E comma F comma G comma H. Anything else? No. After that, points on the exterior, these are Q and S. These are Q and S. So that's it. That's about question number 5, and that's about exercise 4C. I hope this exercise is also clear to you. If you found any sort of doubt, make sure you do ask me. So that's all for this video. Thank you and have a nice day.